Hey guys, here's your notes on Newton's second law. Uh, Newton's second law is a formula. The formula is F net equals ma, where m stands for mass, a stands for acceleration, and F net is the net force on an object. Really, Newton's second law doesn't say anything new, anything more new than Newton's first law. It just adds it basically states the first law of inertia, but it does it mathematically. Alright, so let's think about how Newton's second law works with net forces that are equal to zero, or, balanced, and with net forces that are negative, that are unbalanced, and positive, that is also unbalanced. Alright, so how does Newton's second law work if the net force is zero? F net becomes zero. M, whatever the mass of the object is, doesn't matter what number it is, and A will always end up being zero if the net force on an object is zero. What are two things that can be happening to an object if the A equals zero, whenever the net force is zero? Two things that could be happening is the object could be at rest or in motion, but whatever it's doing, acceleration equals zero means there is no change in the object's velocity. So it doesn't speed up or slow down. So if it's at rest or in motion, it will remain. And you already knew that. So that's why when the net force is zero, mathematically you could see there's no acceleration and it remains either at rest or in motion. Remains either at rest or in motion. Just saying first law mathematically. When the net force is negative, net force was a negative number, say, let's just plug in a number there. -5, for example, is your net force. What if that's your net force? Whatever your m is, your acceleration will also be some negative acceleration. What does that mean is going to happen to the object? When the net force is negative, the acceleration is negative. You gotta slow down. So you can imagine if the net force is positive, say it was +5, then your acceleration is going to end up being a positive acceleration. Some sort of positive number there for A. So when you have a positive net force, you have a net positive acceleration or a speed up. And that's just how the equation shows that. You could see that if your left side of your equation is negative, you're going to have a right side being negative acceleration. If your left side net force is positive, then your right side will be positive acceleration. And if the net force is zero, there will be no change in speed, no acceleration. So whether it's rest or in motion, it will remain. And that's how Newton's second law is just a mathematical way of saying what Newton's first law already says. Let's talk about mass. Alright, the effect of mass in this equation for Newton's second law. A large mass means a large inertia. So in our equation, if you have a large mass, for Newton's second law, the larger this mass gets, the smaller accelerations you get. So think here, the bowling ball. Large mass was difficult to change its velocity. This is called a inverse proportion. When mass goes up, acceleration goes down. If you have a small mass like the styrofoam ball, small mass will mean you could achieve great changes in speed in relatively small amounts of time. So the styrofoam ball was pliable, it was light, had a small inertia, small mass. When the mass goes down in this equation, to make the same net force, you got to have a larger acceleration.